পিপিটি আছে না? না এটা না তো, আমার পেন ড্রাইভটা লাগিয়েছেন? আসেনি এখনো। পিপিটিটা, হ্যাঁ। স্লাইড মুভ করবো কি করে? হোল্ড করবে তো? না না, মানে এখানটা দেখি এক মিনিট। ঠিক আছে। Good afternoon, everyone. Now I am a little bit tense because this is my first presentation in Calcutta Logic Circle. So first of all, I would like to say thanks for giving me this opportunity to share my thoughts. But I am now I'm a learner and I don't have much more knowledge, but I will try my level best. Please forgive me for any kind of unwanted mistakes from my side. Okay? So the topic of my presentation is possibility of imperative logic. The logic imperative sentence, which is deal with imperative sentence. So imperative sentence we found in language. So what is language? Language is the tool of human communication. It is the medium of expressing ideas by means of speech sound combined into words, and words are combined into sentence. Sentence is the basic unit of language which express thoughts. So declarative sentences are mostly used sentence type in our everyday life and in any scripture. But in moral philosophy, there are other type of sentences which is grammatically similar with descriptive sentence, although their linguistic function is different. This is called evaluative sentences. A great deal of 20th century moral philosophy sustain a sharp distinction between descriptive and evaluative judgments, which may be considered as is-ought problem. The primitive form of distinction between descriptive and evaluative judgment was first traced by David Hume. This the evaluative judgment, the descriptive judgment asserts some facts, so it is either true or false, and this type of sentence is empirically verifiable. On the other hand, moral judgment, and Hume used the terminology of emotive, express speaker's feelings or emotion. So it can't be empirically verifiable. They are meaningful, according to Hume, only in psychological context. Okay. Now, after Hume, G.E. Moore, according to Moore, neither we can define a moral concept nor can define an ethical conclusion from descriptive sentences. If anyone try to do this, then he or she make a big mistake, and according to Moore, it is called naturalistic fallacy. Ethical terms, for Moore, ethical terms such as good is a simple notion. If anyone asks what is good, then the answer should be good is good. That is the end of the notion. So we cannot define any moral concept by ethical, by descriptive or factual concepts. So we cannot derive value from fact for Moore. Okay. Now it's come to here. For here, no imperative conclusion can be validly drawn from the set of premises that do not contain at least one imperative. For him, the language of moral is one sort of prescriptive. It has some action guiding function. According to him, such imperative sentences have some action guiding function, though the theory of here is called prescriptivism. So, Hume, Moore and Hare all holds that ought statements are different from is statement. We cannot derive one from another. So now the question is, the imperative sentence, or the basic problem of my paper is, imperatives are not truth preservative. So we cannot include them in the domain of classical two-valued logic. So what is for imperative? And imperative sentences are very useful and is inevitable in our everyday life. Okay. So we cannot ignore imperative sentences. So we have to formulate a new logical system for imperative sentences. Let's see. Okay. So history shows that there are three approaches for imperative logics. The first approach, imperative logic is not possible because they are not truth preservative. Imperative sentences cannot be considered as premises or conclusion of any inferences. The first proponents are mostly logical positivists because they thought that imperatives are cognitively meaningless. They are only meaningful in psychological context and it expresses speaker's feelings or emotion. Okay, this is the first approach. According to the second trend is to show that imperative sentences can be translated into declarative sentences. So the imperative sentences can be treated in the framework of classical two-valued logic. This is called reductionist approach. For example, do X. This is a command imperative, and for reductionist it can be translated, I command you to do X. This is a descriptive sentence. So for them, imperative can be included in the domain of classical two-valued logic because they can be translated into declarative sentences. So there is no need to formulate another logical system for imperative sentences. Okay. Now the third approach. According to the third approach, imperatives have some unique features and cannot be reducible into declarative sentences. So there is a need to formulate a new system for imperative sentences. This is called non-reductionist approach. Now my today my focus is this non-reductionist approach, and I must say the updated version of imperative logic which is offered by Peter B. M. Vranas and then Josh Parsons. Okay. So the next slides. Actually, they are the proponents of first approach. Due to time constraint, I not elaborate the theory of Rudolf Carnap, A.J.R., C.L. Stevenson. I just keep this, okay? If anyone asks me the questions, then I will. Reductionist approach. The command theory, do X can be translated as the corresponding performative utterance, I command you to do X. Desire theory is another reductionist approach. They thought that do X can be translated as I want you to do X. Deontic theory is Kant's theory. Kant who equated imperative sentences shut the door with the deontic proposition you should shut the door. And G. Bonnard, who is the founder of elliptic theory, get out from my house. Here the hidden disjunctive sentence is either you get out from my house or I will call other people to make you get out of the house. This sentence is true if at least one disjunct is true. In this way, they include imperative sentences in the framework of classical two-valued logic. They translated imperatives into declarative sentences. Okay, but non-reductionist approach, non-reductionist approach, Alf-Ross is a non-reductionist approach. He told that imperative inferences may be valid and they can be satisfied. He introduced the new notion, logic of satisfaction for imperative. Imperative does not describe facts, so it can't be considered true or false, but they can be satisfied. Here also a non-reductionist, here also says that two rules for imperative validity he proposes. According to him, logic of imperative is possible and it must be innovative. He makes a distinction between phrastic and noustic elements of the sentences. Okay, now my main focus is Vrana's and Parsons theory. So I move on to Vrana's theory. Sorry. Okay. This is the Vrana's theory. Peter V.M. Vrana offers a new formulation of imperative logic in his paper In Defense of Imperative Inferences. Vrana argues that imperative sentences are very useful in our everyday life. A process of reasoning can start by endorsing an imperative sentences. He introduced two values for imperative: satisfaction and violation. Okay, two values. And Vrana also said that imperatives have unique features, so we cannot include them, we cannot translate them in the to the declarative sentences. So you have to formulate a new logical system for imperative sentences. Then I will see how Vrana said. Vrana introduced two values for unconditional imperative sentences or prescription, which are analogous to truth and falsity, the classical two-valued logic. These two values are satisfaction and violation. Prescription cannot be considered as true or false, but it can be satisfied or violated. A prescription, for example, love him. A prescription, love him, is satisfied if hearer loves the person talked about, and violated if not. According to the Vrana, the second analog is bindingness and non-bindingness. Love him, which is prescription, is binding if there is a reason to love him, and non-binding if there is no reason to love him. For Vrana, a conditional prescription has proposition as its antecedent and consequent part is a prescription. So for Vrana, this is an example of conditional proposition. If he proposes, then you will marry him, and it is true even if the antecedent is not true. A false antecedent can entail a true proposition. This is the not conditional prescription. The first example is conditional proposition. Okay. For Vrana, there are two types of imperative arguments: pure imperative arguments and mixed imperative argument. A pure imperative argument has prescription alone as both premise and conclusion, but mixed imperative argument has a proposition and prescription as its constituent part. According to Vrana, moral claims which are imperative are considered as neither true nor false can be dealt with an imperative logic only. Okay. So, I already said that Vrana has considered two values for prescription, satisfaction and violation. Now, it may be said that imperative logic is isomorphic to classical two-valued logic, because like classical two-valued logic, imperative has also two values, satisfaction and violation. But for Vrana, the uniqueness of this imperative logic has been retained by the distinction between conditional and unconditional prescription. Now move on the conditional prescription. First, conditional prescription. If you love him, then trust him. It cannot be considered either satisfied or violated if the antecedent does not hold. If you do not love him, then the conditional prescription is neither satisfied nor violated but avoided. So, for Vrana, the unconditional prescription has two values: satisfaction and violation. But conditional prescription has three values: satisfaction, violation and avoidance. Okay. So, there is the uniqueness of imperative logic. Like classical two-valued logic has two valued, but there is the three values: satisfaction, violation, and avoidance. Okay. So in his paper, New Foundation of Imperative Logic, Logical Connectives, Consistency and Quantifiers, Vranas deals with negation, conjunction, disjunction, conditional and also biconditional. He also considers three criteria for determining the validity of imperative arguments, namely satisfaction, bindingness and obedience. There are three criteria for determining the validity according to Vranas for imperative argument. A pure imperative argument is satisfaction valid if its conclusion is satisfied, and when conclusion is satisfied, then the conclusion is satisfied if the conjunction of its premises is satisfied. Then a pure imperative argument is bindingness valid exactly if necessarily its conclusion is binding, and when its conclusion is binding, if the conjunction of the premise is binding. On the other hand, the last obedience criteria, if the consequent of a hypothetical sentence is obeyed, then the pure imperative argument is obedience valid, and the consequent is obeyed if the antecedent is obeyed. Okay, I also explain this. Okay. So this is the Vranas theory. Vranas explain imperative logic in this way, and he also told that imperatives is the different unique features. So we cannot, it's not truth preservative, but is satisfied, violated, and conditional. In case of conditional prescription, it is satisfied, violated, or avoided. Now we move on. The another theory, which is the latest work on imperative logic, George Parsons introduce a new notion which he call pre-proscription. According to him, the content of sentence is pre-proscription. It's not proposition, it's a pre-proscription. Then what is pre-proscription? Pre-proscription is a set of ordered pair in respect of all possible world. Let us suppose that there are four possible worlds. This is the four possible worlds according to Parsons. First, WFA, in which may take an example, in which weather is fine and you attack at dawn, is the first possible world. Second possible world, in which the weather is fine and you do not attack at dawn. Third possible world, in which the weather is not fine and you attack at dawn, and the last possible world in which weather is not fine and you do not attack at dawn. There are four possible worlds according to Parsons. How Parsons explain the logic of imperative, now I will describe it. We can represent all possible combination of the worlds in the following way. Here each cell represents the pair whose first member heads its row and second member heads its column. There are the table of possible worlds. There are 16 pair the possible worlds. So the weather is fine. Suppose this is a sentence, descriptive sentence, the weather is fine. So how we, the weather is fine, the now for slide the delay. Sorry. The weather is fine. So this is a descriptive sentence. So we look at the first member of our cell. So this cell, the weather, sorry. So we can explain it this way: the weather is fine. This cell are ticked. The weather is fine. Okay. Attack at dawn. Attack at dawn is has a compliance condition because it has a it is a imperative sentences. So we look at this cell, this cell. Alright. So this is these cells are ticked. So attack at dawn. Now we move on the conditional command. there was a simple comment, it's a conditional comment. If the weather is fine, attack at dawn. This is a conditional comment. If the weather is fine, attack at dawn is equivalent to either the weather is not fine or attack at dawn. Okay, P implies Q. We can, if this is equivalent, negation P, vel Q, material implication. Okay, so this is the table of this sentence. If the weather is fine, attack at dawn, which is equivalent to either the weather is not fine or attack at dawn. This is the table of this sentence. We can translate this sentence, material implication, like this. Okay. Next slide. Now we move on the argument. The argument form is attack at dawn if the weather is fine, the first premise. Second premise is the weather is fine, and the conclusion is therefore attack at dawn. Now persons explain how she demonstrates this argument in table, and this is the second argument. Flee for your life only if our plans are betrayed. You flee for your life, therefore let our plans be betrayed. This is a first of all, this is invalid argument, the second one, and the first one is this is a valid argument. Okay, so the table shows that how this argument is valid and this argument is invalid. Okay, table ta kora ache. Okay, so P for flee for your life and symbolize Q, our plans are betrayed. Okay, so we can symbolize in this way. P implies Q, which is equivalent to negation P for vel Q. Here P is imperative and Q is declarative. Okay, flee for your life, this is an imperative sentence, and our plans are betrayed, this is declarative sentences. So we can symbolize the table this way. Satisfaction and violation. Satisfaction logic and violation. True means
the condition in this type of sentence is if the weather is fine, then attack. So if the condition is fine, we'll have true values, right? And then attack will have satisfaction values, right? So you are not making any distinction in the table. Right, am I correct in this understanding? So when you that you are showing actually, so everywhere we get same type of tick marks.
Acha. Okay, sir. Yeah, sir. A slide there, chalo. 1 minute.
So mixing up both true, false on one side and satisfied.
Actually, sir, persons say declarative have belief condition, and in imperative has compliance condition. Okay, so the first member heads its row and second member heads its column. I already said that. I'll show the column. One, sir. Yes, sir. First member heads its row and second member heads its column. Okay. Now this is the declarative. The declarative first member. Second member imperative. Okay. It has compliance condition. It says belief condition, true condition. Okay. So it's the first member, it's the second member. When I symbolize the declarative sentence, the weather is fine, we look at the first member, the weather is fine. Then these cells are ticks, these cells are ticks. The weather is fine absent these cells. We not look at these cells because they are for imperative sentences and they are for declarative sentences. Can I explain? Okay, the second, yeah, attack at dawn, it's the imperative sentence. So it has compliance condition. So this, we look at this member, attack at dawn present here, so we tick this, and attack at dawn present here, so we tick this sentence. Okay. Sorry, sir?
You have to put them together, right?
Yeah.
So do you have any picture for that? See what happens in the two tables. If you have P and Q, material application. P is Q, Q is so on, so on. So I have that kind of thing in mind. Right?
Yeah.
So here also I want to see pictures of that sort. But what is the expression of this one?
This is the conditional comment. If the weather is fine, attack at dawn. This is the conditional comment. It can be equivalent to material implication. Okay. P, this is for P, Q, P negation P, vel Q. Either the weather is not fine or attack at dawn. Either the weather is not fine is a antecedent part. This is a declarative sentence. The weather is not fine. Declarative sentence. So for declarative, we have to see this. Okay. So the weather is not fine. The weather is not fine. This cell and this cell. So ticked this cell and this cell. The weather is not fine. F is not present there. The weather is not fine. And the imperative part, attack at dawn. This is the imperative part. So now we look these cells. So attack at dawn presents the weather is fine or attack at dawn. Yeah. Yeah. 1 minute. Attack at dawn. Mistake. Yeah. This sign, this and this. Attack at dawn. Here present attack at dawn. Here present attack at dawn. Okay. Actually, I not repeat the same table here because this table also that's why this is the argument form. So if I repeat this, so we all same table. That's why I not repeat the argument. This is a new table, new stock of world. Okay. Flee for your life only if our plans are betrayed. You flee for your life, therefore let our plan be betrayed. Here, new stock of world. Okay. Flee for your life, our plans are betrayed. Can symbolize this P implies Q, which is equivalent to negation P will Q. Here P is imperative and Q is declarative. P portion. Okay. So new stock of world PQ. Here the table. Flee for your life only if our plans are betrayed. So we can symbolize this way. I can explain it. You flee for life. It is simple declarative sentences. So we can demonstrate it like this way. Not I. Persons can explain it this way. This is a person's example, not my example. Persons in his book, Command and Consequences, elaborate in this way. And thus, let our plan be betrayed. This is also an imperative conclusion. So he can explain it this way. Okay. Sorry, I can't attack. So if we notice, there are 6 cells. There are 6 cells which are ticked in both number 1 and number 2 matrix. This is number 1 matrix in case of this argument. This is number 1 matrix and this is number 2 matrix. Okay, and this is conclusion for this argument. So there are 6 cells which are ticked both number 1 and number 2 matrix. So these 6 cells are not all ticked in number 3 conclusion matrix. So for persons this argument is invalid. This way he explained validity and invalidity for imperative sentences through the help of possible worlds like this way. Okay. So indicative and imperative differ in content, not in force for person. The content of imperatives are pre-prescription. Pre-prescription is a representative of person's belief and intention. A prescription is a set of pair of words whose first member has to do with belief and second has to do with intention. Okay. So the main problem is that Vrana's theory is also good. Vrana's has tried to discover new notions for imperative logic. But the problem is Vrana's do not consider the notion of intention, the value of intention in case of imperative sentences. Because imperative involve intention. Intention plays a very important role in case of imperative sentences. Human communication attempt to change addressing mind in various ways. When the communication when is successful, when the communication is successful if when speaker says something, hearer understand what speaker says and he try to do this. So the intention between speaker and hearer and speaker, intention must play a very important role, but Vranas do not consider the term of intention, the place of important roles of intention in case of imperative logic. He only considered two values, satisfaction and violation, and the three values for conditional prescription, satisfaction, violation, avoidance. So it may be also said that in case of unconditional prescription, it would be isomorphic to classical two-valued logic, because conditional prescription has two values, unconditional prescription, satisfaction and violation, like classical two-valued logic, true and false. So Vrana's terminology is very difficult and very complicated. So Parsons is the only philosopher who tried to explain imperative logic in terms of possible worlds and in terms of he admit the role of intention in case of imperative logic. So now the time limit, I must conclude that Parsons' theory amongst the best theory till date. I am a research scholar. I work with imperative logic, and I also try to find out my level based what is the intention and what is the more work imperative logic, because it is very important. The computer programming, now AI, artificial intelligence, all actually deals with imperative sentences. So we cannot neglect imperative sentences by saying that the imperatives is not truth preservative, it just express speaker's feeling or emotion. So we no need to formulate a new system for imperative. So we all consider the imperative sentence for logical system. We have to formulate new system. That's all. Thank you.
I have a little query regarding the Parsons' theory for formulating imperative logic. That is my quest for when Parsons is trying to put the values as you shown into the chart, when you were replacing with 4 columns, okay, placing 4 columns. I just want to know one thing, that is, how do you put a value of a imperative word, like it's very fine. When I think there is certain degrees of that. Those are the qualitative word, na? So when we try to put certain values of those words, then which criteria should we follow? First thing is that, my first query is that. And the second one is it acceptable by each and every understandable person that, suppose when we take a blue color, then it must be a different kind of shades of blue. So if I agree that this is number 1 shade of blue color, and any other one may say that this is a 4th number of shades of blue color. Then how do persons imply the truth, notion of truth and falsity with the notion of the descriptive notion of truth and falsity and the imperative notion of truth and falsity. How do a person incorporated them into a certain cell?
Actually, persons try to say that descriptive true false and imperative true false is different. True false, this notion true truth false, actually imperatives are not truth preservative. That's the problem. If imperatives are truth preservative, then we no need to talk about imperative logic. The imperative already include the domain of classical two-valued logic. Because of that, imperatives are not truth preservative. I cannot say this is true, this is false. The weather is fine, I say. The weather is fine. This is a descriptive sentence. I will say sit down. This is imperative sentence. So I cannot say that sit down is true, the truth value true. But I cannot say that sit down is false, falsity. We cannot say that. What is the actually persons try to introduce the intention. I want you sit there, and you
There must be some sort of label, na?
label influenced.
Yeah.
Actually influenced.
Someone may understand that it is one kind of hardiness to describe me as to sit down.
Yeah.
Someone may say that it is a comment.
Yes.
Maybe.
Huh.
So how do we understand the meaning of that phrase, sit down, which would it refer?
Actually, it's a psychological context. Psychology is different man to man, isn't it? So,
Because we put an example where we can find that one descriptive statement and the other one is imperative. Then when we are placing a chart where the rows are
it's a mixed imperative. This is a mixed imperative, not pure imperative.
I just try to understand that thing. When we have the row, those representing the descriptive statements and the column are for imperative statements, then how do we construct into one cell where description and as well as the imperation both existed?
Yeah, there's consequence. Actually, this is mixed imperative argument. Though, for mixed imperative argument, either the antecedent part is descriptive or consequent part is imperative. Mixed imperative argument. In case of pure imperative argument, where all premise and conclusion all are pure imperative.
When we put a block that is one that is the
Here,
first box where there is some sort of description.
I
as
can
well as
understand.
Some sort of imperation. Now, how do we calculate that thing, that box? Is it imperative or descriptive, or it may be mixed?
Mixed.
How do we put the value of that particular box according to person?
Actually, there is all criticism against person. I'm just not that for time constraint. I'm not elaborate this. There are lots of criticism of persons, but my point of that. The role of intention, which is the most important thing in case of imperative, because imperative cannot be, we cannot describe imperative sentences for minus the intention. We have to consider intention. So this logical system for imperatives, we must consider intention, and person is the only person or only philosopher who try to consider the role of intention in the domain of this. There are lots of criticism against persons, and as a research scholar, I try to work with this. Thank you.
Okay, we thank the speaker one more time, and I hope that if you have any other questions, like you may ask him during the tea time, since we are running late. So just put a hand to the speaker one more time. Thank you, Rita.
Thank you so much.
And now, we have again changed the order a bit of our program. So now, for the next 10 to 15 minutes, the open session will take place now. And then I am handing over the mic to Professor Mihir Kumar Chakraborty, who is going to conduct the open session.
No, actually, I stand over here and then I speak. In fact, I wanted to have this session because there are some new faces this time, quite a number, but now the number has reduced already. So I wanted to know how and why the new participants of CLC got interested in logic, and what kind of work they are doing, that may take long time, but main interest is this. Reason of my asking this question is the following. When, say, about 10-15 years ago, there was, in India at least, we found quite a good number of enthusiasm, good amount of enthusiasm in study of logic, in basically in 3 departments: mathematics, philosophy, and computer science. These 3 departments. In Calcutta Logic Circle also, we had participants from these 3 streams of people. But that has declined, to my understanding. That has declined. So I feel that not too many students, not too many researchers are participating, are showing interest at this point of time, at least in India. So I feel quite happy to see so many new faces. And I wanted to know what brought them in this domain. That is, they historically or psychologically or, yeah. So any of you, maybe I can ask, because they are trying, in Guwahati, they are trying to organize some, open up some kind of hub of logic. So Shantanu, I can invite Shantanu to open up the discussion. And then it will not continue for quite a long time. So I think 2 or 3 of you are there. Maybe she also. So we take 2-3 minutes time altogether and say something. Shantanu, please.
Thank you, sir. And it's a long journey to be here. Actually, I never thought that I would have the opportunity to be in a conference of logic in my lifetime, because I started my career as a topologist and expert of soft computing sites. In the mid of my career, I think probably in 2018 or 19, I became interested in AI and human consciousness, human intelligence, etc. And there was one important open problem. It's called Smell's 18 problem. Stephen Smell, Fields medalist, 18 problem. Like as all of you know that Hilbert's problems are there, 21 problems or 22 problems is a list of 21, 22 problems. So Smell also proposed one list of 18 problems to the mathematicians, and the 18 problems was very interesting to me. The statement is, what is the limit of human and artificial intelligence? And when I went through this question, I became very fascinated to this question, problem, that, yeah, it's important. Is there any limitation of AI? Or is there any limitation of human consciousness? And I don't know whether it's my destiny or something else. So at the same time, I was interested in psychology, philosophy, social networking, etc. I read one book, Topological Psychology by, I forgot the name of the author, Topological Psychology, Principles of Topological Psychology. And I started to found that, okay, topology is going to play a good role if I want to attack the problems or AI and all these things. And then I started thinking. And when I started to think to solve the problem of human intelligence, limitation of the human intelligence, I found that topology is a good tool, but if I will not jump into logic, then probably I am going to missing something. And again, probably destiny was with me. So I found some papers of Alfred Tarski, basically consequence operator. And when I read the consequence operator and related papers, I found some clues that can be used to solve the problem. And then I, along with my scholar Upasana, we tried to solve this problem, and finally we became successful to show mathematically for the first time that yes, human intelligence is limitless. And that's how my journey with the logic started. And in the meanwhile, I started to looking for experts of the logic in India. I was not familiar about Sir. I found the name of Mohua ma'am, so because Rafset is there, okay. And then when I was searching his profile, so I searched who is his supervisor, who is her supervisor. So somehow I came to know about Sir. Then it was in my mind that okay, let's start a hub of research in logic in my department, because in Guwahati University logic is there is a paper in mathematical logic. Even I took that paper when I was in my MSc, but in my university, so only one PhD thesis is available on mathematical logic. Probably it was done nearly 45 years ago, and the madam who did research in logic, she died immediately after that, but no research has been done so far. Then it was my intention to start logic in my department as a research, and thus I came to this conference. And as far as my other areas are concerned, like big data, social networking, etc., so there is also one topic in belief, if I am not belief system, like belief logic, etc. So in social networking area also, logic has been playing good role. How to build up the society, how people communicate with each other, how logically they are connected with each other. And even in big data, when we just analyze the big data, or we just find information from the big data, because it is dynamic. So I found that yes, logic is going to play a good role, and thus I am interested in logic. So now, because of Sir's encouragement and all of you, so I am here, and it's my journey. Probably it's my new journey, I hope so, because I never thought that I will come in a conference of logic, because I'm nowhere connected to logic. Thank you very much.
Thank you, Shantanu, for your for the story of your initiation in this area. Now, please, some of you come here. Introduce yourself first.
Hello, I'm Shougata Bose. So I did my undergraduate in CMI, so that's when my interest in logic started. So, and then I went on to do a master's in computer science and then a PhD from Bordeaux. So I am mostly working in automata theory, game theory, and these related areas. And so my interest in logic comes from the connections to logic, such as MSO, first order logic, and so on. And then during my postdoc, so I'm currently a postdoc in Liverpool, and I'll soon be moving to Belgium for another postdoc. So during this time, I'm working on game theory, and so there are some connections of game theory to first order logic over reals and so on. So that's where, so I won't say logic is my primary area, but since there are some connections, and also because Jam and Kamal, so we attended some of the courses and some seminars at that time when I was in Chennai. So that was the reason. So I found out about this conference, Calcutta Logic Meet, from this. I think I was just looking at ICLA's website, and then I just found out about this. So that's how I came here. So yeah, and it's been very nice for the attending this for the 2 days, and I've because I'm coming from more computer science background, I also learned a lot of new things, which was very interesting. So thank you.
Thank you very much. So you please. Oh.
Hello. I'm Suman, and we have kind of very similar background. I also did my undergrad at CMI, and then I was introduced to mathematical logic there, and formal methods, automata theory, and other stuffs. So currently, I'm a postdoc at University of Haifa, and I'm working mostly in games, and where we see logic to specify, to use writing specifications that we want as a, say, winning conditions of a game or something like that. So yeah, I'm also not exactly working in the field of logic, but we use different type of logic in formal verification because, yeah. And I was here because of the current situation in Israel where I was doing postdoc, and I'm currently working from home. So I came to know actually from him that this is happening. I have heard about this circle before, but I was not sure that what is being studied here. So I was, for example, the perspective from philosophy in mathematical logic is kind of quite new for me. At least academically. I have been reading stuff like from other philosophers from 20th century who have worked on logic, but I didn't know how it is being worked currently. So that is a new thing that I'm taking away from this 2 days seminar, I would say. Thank you.
Thank you very much. So thank you. And now, Soel, will you say something, please? এরপরে ও বলুক, তারপরে আমরা ওয়াইন্ড আপ করি।
Hello, so my name is Sohel Hussain. So this is my second year actually. Last year I gave a talk here. So actually I was doing my undergrad. When I was trying to learn mathematics, so I found few things very interesting, such as how an object is defined and how the proof system works. So that thing, the idea of proof or defining something in some formal language, actually, I was interested on that mostly at that time. So then after a few years, I read few things like Cantor diagonalization, proof of the Cantor diagonalization problem. Then I started discovering new things in logic and set theory, for example, axiomatic set theory, then Gödel's work. So naturally I was interested in logic, but then I met few people. Firstly, Sodov sir, he is my professor, so I came to know that he worked in logic and paraconsistent logic and something. So after my graduation, I was actually very confused that what I should do, and I anyway did my masters, and then after I came to know about Mihir sir somehow. Then I joined School of Cognitive Science and have this opportunity to work with him, and he's a great inspiration to me, and he somehow gave the scope to me to work under him, and I did some work on diagram logic, and now I'm looking for my further studies, and I did some work in logic, and that's all. So so from these people I came to know about this circle, and I really enjoyed this community so in India we all know that from mathematics department or those who do mathematics, people don't encourage enough to do logic or philosophy or some other thing. So that is what I faced actually from my experience. So being a part of this community feels very great, and I think I'll do some work in the future. So thank you, sir.
Okay, thanks, Joel. And now, to me, please, Pritha. Pritha, is name Pritha. Yes. She is from Philosophy Department, as we already know.
I'm Pritha. I'm Assistant Professor at P.R. Thakur Government College, and I'm also a research scholar from University of Calcutta. And I would like to say thanks for giving me this opportunity. Here, the all stalwarts person sitting here in front of them, I'm very fortunate. In front of them, I'm sharing my thoughts. Thank you so much. My mom is admitted in hospital. She is fighting with cancer. So I have very hurry to leave. That's why I told the sir, please leave my presentations early. But I can't leave the room because so interested talks delivered here. So thank you so much. Thanks to Monideepa ma'am. Thanks to Mihir sir. Thanks to Saurabh sir, Palashis. Thanks to all of you. Thank you so much.
No, actually, we wanted to know how did you get into it. Anyway, so let us stop here. Thanks to everybody. Will you say something? Anybody else? তুমি কিছু বলবে? আসো. Say something. Shoel বলেছে. You come. কি নাম জানো?
My name is Samaun Mondol. I have completed my MPhil degree of Jadavpur University, and my MPhil dissertation is on Mariology. Mani ma'am talked yesterday on Mariology, but my topic is metaphysics and logic background, and I I trying to my PhD thesis on logic. Okay. Thank you.
So it's not very well done because we couldn't give too much time and we didn't have the full audience today. We still have 2 more talks. So with thanks. Kamal, will you say 1 or 2 words to everybody? Because to the younger people, to the younger people.
Well, like I said, I've been in CLC a long time ago, and I didn't come for a long time, so maybe that's why I'm being treated as a new member. But I just want to say how I got into logic, which is I'm an engineer by profession. My undergraduation is engineering, and I was working with computers, programming. That's the kind of work I was doing. And then I realized that programs can make so many mistakes. And then I got interested. There are so many bugs in programs. And I started to see if I could find some way of showing that a program actually does what it is supposed to do. Okay? And that is something which got me interested in. Then I realized that there is one branch called logic, which actually studies what is truth and how you prove truth and so on. And that's how I got into logic. So actually, there were 5 of us PhD students in TIFR, I was there, Ramanujam was there, who was Jam, whom we call, and there were 3 others. And what happened in TIFR, it's quite a sad story, which is one of our faculty members left. Then another faculty member went away for a sabbatical for 3 years. So there were just 5 of us supposed to do PhD, and we were sitting there. So we decided to teach each other. And we started like CLC, we started basically a session for talking to each other. Except that the rule was the following, which is that at TFR there is this phenomenon called 10 p.m. tea. At 10 p.m. at night you get the last tea in the canteen, after that canteen is closed. So we would start after the 10 p.m. tea. And somebody would present and would discuss and so on. And that's how I learned logic. A lot of us got interested in a lot of problems and learned from each other, not just logic, other things also. So I think it's always a good idea to have, as someone said just now, a community of people with whom you can discuss work. So that is the importance of Calcutta Logic Circle.
Actually, Kamal has raised the main issue already raised by somebody else. That is the community to development of the community. Saurabh, for example, has experienced the vibrant community of logicians in South America, recent. Because I have been also there, so I can feel, Shonko also can feel, I think, because being there and having a feeling of the community is something which makes you excited, at the same time happy, at the same time creative, and so on. So I think it is a high time for us also in India to create the community. Already Ali is there. That's quite, it's a culmination of the effort. That's quite good. And Ali is organizing 2 events, successful events, alternative year, ICLA and ISLA. So that's good. But yet I think the community is not that vibrant as we have seen in some other places, for example, in South America. This is actually my desire. I will be 80 next year, formally. So I want to say less, bit less, at least 1 year less. Anyway, but that's quite long, journey. My journey was also similar. I had to start from scratch. Nobody was around. And so everything has to be, created, constructed, and so on. Anyway, that is a good experience also. Now at least we have some people around. We can at least see some faces, some. This time, what in this CLC, less representation from philosophy. That is a bit not usual in here. So next time you must, I think we should be careful about that, a bit more careful. Okay, thank you all. Now I hand over the mic to Saurabh again.
So I think we should put a hand for ourselves. So it's a good open session. But since we don't have much time, I think that it's better that we first go for tea for 10 minutes. And then we come back here and then we go for the next 2 talks. Okay, so it's a break for tea for 10 minutes. So we'll meet here again at 4, it's 4:10 now, so 4:20. Okay. Yes, yes. Well, let's start the session after tea. And this is the only time in the total day that where we are starting before time. So we told 4:20 will start. It's 4:18. So let's start with Shantan Roy. So he completed recently his PhD under Professor Shankar Subra Bosu from IIIT Delhi. So he is just after finishing it, he has come to Kolkata from IIIT Delhi, and directly he has come here and giving the talk on his PhD thesis. So it's over to you, Shantan, please.
Yeah. So thank you very much for the introduction. As I said, so this talk is coming straight from my PhD thesis. It is on Shusko's thesis, inferential many-valuedness and many-valued logic. Sorry. This is a joint work with my advisors, Shankar sir and Mihir sir. So let me start with the outline of the talk. First I will provide some background, then discuss the aims for this talk, and finally outline some fundamental notions, talk about inferential many-valuedness, and then a generalized version of Shusko deduction on which the Shusko thesis is actually based. And based on this generalized version, we will propose two conjectural generalization of Shusko's thesis and finally point out some future directions for work. So let me just start with the definition of a matrix for a logic, which is usually defined to be a pair of this form AD, where A is an algebra similar to the proposition language L, and D is a subset of A, usually called the designated subset. To each such matrix, one can canonically associate an entailment relation, which is defined like this, like gamma entails alpha, if and only if for every homomorphism, this hom is the set of all homomorphisms from L to A, for all homomorphisms V gamma, all the elements of gamma under the application of V, if this is inside D, then V alpha also is inside D. We say that logic is bivalent or two-valued if the cardinality of A is 2. That's all. A many-valued logic is usually understood to be a logic, V gamma. V gamma stands for the application of V on gamma. I mean, it's all the elements of gamma. You just apply your function. V is a function, right? So a many-valued logic is generally understood to be logic. It's not bivalent in the sense I just described. So it has many examples. For example, Lukashevich logics, post logics, and Gödel logics. These are just some of the examples. So in 1977, Roman Shusko showed that the three-valued Lukashevich logic can also be given a bivalent characterization using a more general notion of matrices. So by more general notion, I mean that if you just remember earlier, I just mentioned that these V's are homomorphisms from L to A. In Shusko's new definition of semantics, it was not homomorphisms, it was just arbitrary functions. That's why he could reduce the three-valued to two-valued semantics. And this process is called Shusko's reduction. In the paper, he just mentioned that this process can be carried out to more general logics, and he left it at that. So the philosophical interpretation of the values thus obtained, by which I mean the two values thus obtained, raised important philosophical questions regarding the nature of truth values and led to the formulation of so-called Shusko's thesis, which states that every logic has an adequate bivalent semantics. By the way, Shusko never formulated his thesis in this precise terms. This is formulated in a later paper. But there is a caveat that Shusko avoids speaking of truth values. Instead, one of his main points is to distinguish between the algebraic values and logical values. The mathematical result, which is Shusko deduction, can thus be paraphrased only after the adoption of a peculiar conception of what is a two-valued semantics, and in particular, what is a semantic. Otherwise, you can't make sense of the term adequate bivalent semantics. So Then multiple ways of understanding Shushko. Since Shushko never precisely formulated his thesis, anyway it's a thesis, there have been multiple ways of understanding Shushko's thesis. Malinowski, for example, in 1994, Suji, Monsing, Stramko have put forward different proposals of understanding ST, and since ST is intimately related to understanding many-valuedness, different proposals of many-valuedness as well. Yeah, so aims of the talk. So the aim is, one aim is the evaluation of ST via different definition of semantics. I will propose to different definition of semantics, and based on that I will try to evaluate, show that whether ST is true or false, and I will just show that depending on your definition of semantics, the truth and falsity varies. Yeah, then I will propose a formalization of the notion of inferential many-valuedness, and finally, and show that there is an adequate bivalent semantics for every logical structure. This bivalent is not the same since in the earlier. I forgot to put quotes here. And finally, I will point out some connections between the theory of graded consequence and the theory of many-valued logics, leading to generalizations of ST. Yeah. So let's start with the fundamental notion. I have already mentioned the logic, but never given any, did not give a formal definition. So here it is. A logical structure is a pair LW, where L is a set and PL is the power set of L. W is an operator on PL. The operator W is said to be the deducibility operator on L. If in particular L is an algebra, we call this pair, we call the corresponding logical structure a logic. So notice that here we don't assume any condition on W, unlike the case of consequence operators. Yeah, so the miscellaneous logical structure, a logical structure is said to be reflexive if whatever is inside it for every gamma, whatever is inside gamma can also be deduced from gamma. Then monotonic if W, the operator preserves the subset inclusion order. Quasi-closed if W gamma is equal to gamma union W gamma. Idempotent if W composed with W, this is a functional composition by the way, equal to W. A logical structure is said to be of Tarski type if it is reflexive, monotonic, idempotent. If it is reflexive and monotonic, then it is called P type, P for plausible. This was introduced by Frankowski. And Q type, if it is monotonic and quasi-closed, this Q stands for quasi. It was introduced by Malinowski. Yeah. So now the definition of semantics. Given a set L, the semantics for L is a tuple of this form, where M is a set. The elements of M is a set, and the elements of M can be thought for the sake of understanding as models. I is a non-empty index set. Transtell is are multiple satisfaction relations on this M. And S is an admissible, S collects the admissible pairs of satisfaction relations that is necessary for us to define the deducibility, induced deducibility operator. So given a semantics, you can have there is a canonical way to define deducibility operator. So you define it in this way: alpha belongs to WS gamma if for every admissible pairs of semantics and models M turnstile I gamma implies that M turnstile J alpha. Now notice that if you have this only singleton instead of this index set, this actually reduces to our, and S is reflexive, you just have the only thing. Then it reduces to our usual notion of usual semantics of Tarski type logical structures. Yeah. So a logical structure is said to be adequate with respect to a semantics S if W equal to WS. It is said to have an adequate semantics if there exists a semantics such that W equal to WS. Yeah. So now the question is whether the definition of semantics we have given is enough or good. This is a theorem that every logical structure has an adequate semantics. So it's good enough. Yeah. Two observations: that the deducibility operator induced from a given semantics is not unique. You can define the deducibility operator in multiple different ways. And second is that the definition of adequacy is also dependent on the deducibility operator, and hence it is also not unique. Next, we come to the notion of inferential many-valuedness. This was introduced by Zygorz Malinowski in 1990s who constructed an example to line up the limits of Shushko reduction by changing the underlying definition of matrix. He introduced something called quasi-matrix or Q matrix, and moreover constructing a non-tertiary notion of entailment which gives rise to Q-type logical structures that I mentioned earlier. So yeah, for this he had the purpose of increasing a third undetermined value at the level of logical values beyond the traditional idea of designated and rejected. He baptized the notion of many-valuedness as inferential many-valuedness. According to him, the usual conception of many-valuedness, like the one I mentioned at the beginning, results in multiplication of semantic correlates of sentences, while the other one is a metalogical property of inference and refers to the partition of the matrix universe into more than two disjoint subsets. But there are problems with this definition because this is as best or as close to a definition he gives. The immediate problem is that whether inferential many-valuedness is only related to the partition of matrix universe. Now he gave examples in which you can partition universe, he gave examples of logics in which you can infer more logical values. But how to check whether a logical structure, a semantics can be given in multiple ways, how to check whether a logical structure is of inferentially n-valued say. He gives no precise definition of that. That's why we tried to, that was the big genesis of this work, and for that we introduced the notion of functionally kappa-valued semantics. So given a set and a semantics S and a cardinal kappa, S is said to be functionally kappa-valued if this is all these properties. Well, I'm not going into the details, just notice that here in this case, the transcell is defined in the way that in the manner we usually define for matrix and designated sets. So it's a generalization of the usual matrix semantics. So if you have a class of functionally, so the class of all functionally kappa-valued semantics for L is denoted by FKL. Based on this definition of functionally kappa-valued semantics, we can define inferentially kappa-valued logical structure. So given a cardinal and a logical structure, it is said to be inferentially kappa-valued if first of all it is adequate with respect to the given semantics, kappa is greater than 1, and then for every functionally many-valued semantics of the same type, I did not define type, but I hope you understand, W is not adequate. So this essentially this means that S is sort of the minimal kappa-valued, minimal functionally kappa-valued logical structure for W. Okay, so and then I will just skip this representation theorem, but this was just to show that a Q-type logical structure is functionally 3-valued because you have 3-value sets over there. But the interesting part is this, that you can, so in Malinowski's case, he never proved that the logical structure is inferentially say 3-valued, he just stated it. So here we can prove using this definition that every non-reflexive Q-type logical structure is inferentially 3-valued. And similarly for others. For example, you can just prove that tertiary logical structure is inferentially 2-valued. Yeah. And so if so ST, Shusko's thesis is falls under this understanding if bivalence is understood as inferential bivalence. On the other hand, now I will propose yes. Which definition of this one? Okay, yeah. Okay, so now I will give a different understanding of Shusko's reduction, and then in this segment I will show that ST is true if we understand bivalence in a different way. So now we propose a notion of Shusko semantics which is similar to the earlier notion of semantics. Instead of that, here the elements, so here it is also a tuple, but notice that here B is a set of characteristic functions and R is just a relation or a subset of B cross B, and turns out there is only one turnstile. Earlier there were multiple turnstiles. So it's this notion of Shusko semantics or S semantics is kind of dual to the earlier notion of semantics, but due to constraint of time I will not go into that. So similar, just as you can define a deducibility operator from a semantics, you can do the same here, and you have a familiar definition. The only important point here is that if there is an adequate S semantics, we call the logical structure to be S bivalent. Now here I just add the word S bivalent because it's a different notion of bivalence than the earlier we have proposed, because here in the earlier case you were only considering characteristic function, but you are also considering the fact that this turnstile is crisp, it is 2-valued. So based on this understanding, and then there is a relation between this semantics and S semantics. So a logical structure has an adequate semantics if and only if it has an adequate S semantics. Now earlier we have shown that every logical structure has an adequate semantics. So from this theorem it follows that a logical structure has an adequate S semantics, and hence by the terminology I introduced earlier, you can just say that ST is true if you understand bivalence as S bivalence. Okay. So yeah, so then so based on this conflicting notion of there are multiple notions of understanding. So what to do with this notion? What is actually the reason for bivalence? That was our question, and that is where we are going for the next part. Thesis. So one of the ways to understand Shusko's distinction between algebraic values and logical values is to interpret the latter as the truth values of the meta theory, while the former would be the truth values of the theory. This is just one way to understand the distinction. You can understand it not as this, but if you understand this in this way, there are richer options for richer avenues for exploration for many valuedness. Yeah, so you can interpret ST in this way: the meta theory or meta logic of every theory logic is two valued. Then the question is, what happens if the meta theory is not two valued? And then an even pertinent question is it even possible for the meta theory to not be two valued? So fortunately, there is this theory of graded consequence comes to rescue, and here, as Professor Chakraborty and Shomam's book they have mentioned, the objective of the theory of graded consequence is to introduce many valuedness to the consequence relation and the other related notions such as this. This is in the same direction that has been pursued during the origination and development of many valued logics. While in many valued logics, object level formula are considered to be many valued, meta level notions like consequence are taken as two valued. In GCT, items of both the levels are treated as many valued. So meta theory can be many valued. That is the whole point of this code. So here is the conclusion that a logic does not live in isolation. To specify a logic completely, one needs to have an idea of the corresponding language, meta-language hierarchy as well. Just as the meta-logic of a given logic can be many-valued, the same conclusion holds for the meta-logic itself and even higher order meta-logics also. Since this hierarchy of language is not unique for a given object language, many-valuedness of a logic is not dependent on the logic alone, but also on the language, meta-language hierarchy. So then interpreting logical interpreting logical value as the truth values of the meta theory makes us wonder about the reason for ignoring the truth values of the higher order meta theory. So the question is, why do treat the logical value as the truth values of the meta theory? Why not truth values of meta theory, and so on? Yeah. So based on this consideration, we propose two versions of generalized Shusko's thesis. That is that for every logic there is a higher order meta logic such that the number of truth values for every meta logic above this logic in the hierarchy is at most as that of this, that of the this L prime trans L prime. And second is for every logic there is a higher order meta logic which is two valued. So if you just particularize this for meta logic, only meta logic, then you get Shusko's thesis. Here this is the same thing. Yeah, that ends the technical parts and direction for future work. Given a set L, is it possible to characterize FKL? Remember that FKL was the set class of all functionally kappa valued semantics for L for each cardinal kappa. This was the problem which motivated us to do this investigation. And then is it possible to find the minimal adequate S semantics for every logical structure which admits an adequate S semantics? Of course, I have not defined what minimal is, but it is possible to define it more formally. And then is it possible to give examples of logics for which any one of the generalization of the Shusko's thesis, as I just mentioned, fails? Yeah, that would be all for today. Yeah, thank you.
Any question from anyone? Okay, come on.
Give an example
Of
where the meta theory is more than two-valued.
Yeah, so that framework is discussed in this gated consequence. I have not studied it in detail, but I just know that it is there. So,
no, how many values is it?
so you can, so essentially the framework, in the framework you have no limitation of values. So for example,
it can be infinite real valued.
So essentially in the framework you take, so as far as I remember, in the framework you have this consequence operator which maps to a set of residuated lattice which has no cardinality restriction.
Okay.
So that way you assign a grade to this consequence relation, which is why this is called the theory of graded consequence, and that way this translation becomes many valued. In ordinary case it is just two valued.
Yeah, but okay. The other thing is, in what you said, there are many nice generalizations of the idea of semantics.
Right.
But what about proofs? I mean, does your notion of proof also generalize, or is it the same, or how does it?
So that's an interesting question. So even though I said semantics, so I did not mention what the translation could be. You can put anything in this translation. So you can put proof theoretic relations also. So it's not, the semantics was just this, because it was a generalization of a concept that was introduced in an earlier paper which called semantics, and I just borrowed that term. But essentially it's just term. I mean, since you are not assuming any particular properties on the satisfaction, I just mentioned satisfaction just to guide the intuition. Nothing, there is nothing there. Yeah.
Okay.
Any other question? Well, if not, so give thanks one more time. Just thank you, Shantan. Just give a hand to him. And we invite our last speaker, Dr. Moshur Rahman Sardar, who is going to be a doctor so recently. And then he is from City College, Kolkata. And he is the last speaker of Calcutta Logic Circle 23rd annual meet. So it's over to you, Moshuddha.
Pocket. Good afternoon to all of you. The title of my talk is Quasi-Boolean based upset theory, a perspective of axiomatization of modal axiom. And in this talk, I will first present the Pavlov graph set theory and its generalization with respect to relation, and after that I will come to the point quasi-Boolean based graph set theory. It was developed by Professor Chakraborty and myself. And then I will move to characterization of standard modal axiom in Boolean based graph set theory, and I will show how this axiomatization of a modal axiom can be done in quasi-Boolean based graph set theory, that is in our system. And lastly, I will present an algebraic approach to quasi-Boolean based graph set theory. So graph set theory, this method was approached by Professor Pavlov in 1982, and this is a constructive approach because two fundamental notions there are approximations operator, and these operators are constructed from some fundamental notion. That's why it is constructive, and initially it was a relation, and later many researchers use covering partition and structure like partial order set, lattice, etc. So this theory starts with this notion approximation space UR, where U is a non-empty set and R is a equivalence relation, and that relation partition the whole set into disjoint classes, and with respect to these classes, lower and upper approximations of two operators corresponding to a set, these two operators have been defined in this way. Lower approximations of A, it is contains those elements whose class contain in A, and upper approximations of A contain those elements whose class intersects A, and therefore here this blue portion, this is the lower approximations of A, and blue, not blue, sorry, green and yellow, this portion is upper approximations of A. And these are the some primary results that these approximations operator are dual with respect to complementation, and this is the Pavlov graph set algebra. The base is this Boolean algebra. So this is Boolean algebra, and along with these two operator, lower and upper approximations operator. And nature of this algebra, it is topological Boolean algebra with counterpart of modal axiom S5. And it is a generalization with respect to arbitrary relation. So here generalized approximation space U rho is taken, rho is arbitrary relation, and then successor neighborhood of each element has been constructed in this way, and using this successor neighborhood, lower and upper approximations have been defined. And this is exactly the same way, just equivalence classes of each x is replaced by successor neighborhood of x. And again, these lower upper approximations are dual with respect to complementation, and these various power set algebras are formed depending on nature of rho. And in case also the base is Boolean. Here is the case is Boolean, and along with these two operators. So this is the case. We developed this system, quasi-Boolean based upset theory. Our notion was that how to incorporate this Boolean base, how to replace our Boolean base by another system which is quasi-Boolean. So quasi-Boolean algebra, this is the power set quasi-Boolean algebra, and this is similar to Boolean algebra. Only difference is that there is a quasi-complementation, and this quasi-complementation is not the standard set theoretic complementation. It is defined by in terms of an involution G, which is a mapping satisfying the condition GGX equal to X. That means double image of the mapping is the same element. And we can easily see that if we take G's identity mapping, then quasi-complementation coincide with complementation, and therefore we can say that this quasi-complementation is more general concept than complementation. And we have also shown that these two notions, that is notion of complementation and notion of quasi-complementation, coincide if and only if G is identity mapping. And this is a quasi-Boolean based upset algebra. Just this base, Boolean base, is replaced by quasi-Boolean algebra. And you know that this, if we consider this Boolean based operator, they are dual with respect to complementation, not dual with respect to quasi-complementation. And that's why we had to construct it two operators which are dual with respect to complementation. Quasi-complementation. And for this we have developed a new relation RG from this approximation space and involution G. So we define the new relation RG in this way. Two elements are related in this relation if and only if their G images are related in the original relation R. And we have shown that this relation is equivalence relation, and with this relation, set with this relation, we called it G approximation space. In this approximation space, we have defined two lower upper approximations operator which are dual with respect to quasi-complementation. So yeah, so we take the G approximation space and we define the lower approximation in this way, and it is very similar to Paulokian, because we take definition is this lower approximation contain all those elements whose class included in A. And upper approximation, we define upper approximation in this way, in this space URG, but after calculation we have shown that this is exactly Paulokian upper approximation in this space UR, not in URG. That means our theory deals with two approximation space at the same time to calculate lower upper approximations operator. And these are dual with respect to quasi-complementation, and that yes. This is the original, and from this relation we have constructed the relation RG, and with respect to RG, this relation G approximation space, we have yes, there are two equivalent relations. RG is defined in this way. RG is no, it is not final. It is just a picture. So from this relation, we got a relation here, and this is equivalence relation. Not it is final from R or smaller like that. Just it is a picture. That is a equivalence relation. And therefore, this quasi-Boolean based upset algebra is formed. It is very similar to Boolean based upset algebra. There was Boolean, and here is this is the quasi-Boolean. And this is the natural question: what would be the nature of this algebra? We have shown that this is the model of topological quasi-Boolean algebra introduced by Banerjee and Chakraborty in 1993. And then we consider the generalization cases, and we take for this arbitrary relation rho, and we define the similar way the relation rho G as the same way, that is two elements are related in the relation rho G if and only if their G images are related in the original relation R. And we take this relation rho G, and we develop another space, and in this space we define the lower and upper approximation in the same way, just only changing the equivalence class of X by successor neighborhood. And we have shown similarly that this is exactly the Paulokian upper approximation in arbitrary space. And then using this lower upper approximation, we have formed this quasi-Boolean upset algebra, and its nature depends on the particular relation rho which is used here. And this is the counterparts of modal axiom. Modal axiom, this is the counterpart of modal axiom in upset theory, and we know that the modal axiom K holds if and only if the relation this holds for any relation rho, and for D it holds if and only if rho is serial, T if and only if rho is reflexive, S4 holds if and only if rho is transitive, B holds if and only if rho is symmetric, and S5, and this is the weak not standard, non-standard modal axiom. It is the reverse direction of S4. Yeah, reverse direction of S4, and this holds if and only if rho is mediate relation, and this is the counterpart of law of excluded middle, and this holds if, for any relation. And this is the concept in Boolean based upset theory. And this is the two definition of what is Euclidean and what is mediate. So a relation is said to be Euclidean if for all x, y, z, x related to y and x related to z imply y related to z, and relation rho is said to be mediate if for any two element x and y, x related to y implies there exists z, such that x related to z and z related to y. That is, it is like converse direction of transitive relation. And now I come to this point, that is, what would be the structure of this quasi-Boolean of this modal axiom in quasi-Boolean based upset, and what would be the relation by which we can characterize these axioms. So this is the K axiom in quasi-Boolean based upset theory. See here, these lower upper approximations are used in quasi-Boolean based approximations, and negation is used for quasi-complementation. And for this we have to develop a relation so that these properties can be characterized. And this is the D axiom in quasi-Boolean based. This is T axiom, this is S4 axiom, this is B axiom, this is S5 axiom, this is reverse direction of S4, and this is intermediate property of 1. And for this we have to develop new type of relation using the involution G. And these are, so we take a relation rho and involution G, then rho is said to be G identical relation if and only if G identical relation if for all x y, x related to y implies gx related to gy. And this is rho is said to be G serial relation if for each x belongs to y, there exists an element y in U such that x related to y and gx related to gy. Rho is said to be G symmetric relation if for all xy, xy implies gy related to gx. Yes? Because if we characterize this modal axiom in quasi-Boolean based upset theory, then the relation which we know like a reflexive symmetric transitive, this do not work here. That's why we involve the particular involution G to capture them. Yes, yes, so that will come later. That yes. No, no. Why G? Mm-hmm.
Because of the representation theorem.
Yes, yes, yes.
Yeah, that is the source. And there is involution there.
No, the Jayantada's question was why G is incorporated in this relation?
Why G is involution?
No, no, G is involution. Why G is incorporated in this relation to define this relation?
Why do you assume that the involution property of G?
Yes.
Involution cannot.
Okay.
For any function, you can define these G identical, G serial, G symmetric.
Yeah. Because we use this function G, and G is not any general function, it is an involution. So it has the property GGX equal to X. Okay, so this is rho is said to be G Euclidean relation if for all x, y, z, x related to y and gx related to z, then it implies gy related to z. And G image equal to rho is said to be G image equal to relation for all x, y, x related to y implies gx related to y. And using this relation, we have characterized this modal axiom in quasi-Boolean based upset theory. So this K holds if and only if G rho is G identical. D holds if and only if G rho is G serial. T holds if and only if rho is reflexive. S4 holds if and only if rho is transitive. B holds if and only if rho is G symmetric. S5 hold if and only if G is Euclidean. reverse direction of S4 hold if and only if rho is mediate, and intermediate property, this holds if and only if rho is G image equality. And with this result, we have developed another axiomatic approach to quasi-Boolean based rough set theory. So in this approach, we don't have any fundamental concept like constructive approach. Here we assume this primitive concept. It is a algebra with two set theoretic operator. One is lower operator and other is upper operator used there. So I have written here U prime. So this these operators are defined by axioms without any reference with reference to any binary relations. And first, these are axioms are needed to define that these two operators are quasi-complementation. So these two axioms are due to their quasi-complementation. And this is the first result, that if we add these two axioms for lower approximation operator U prime, first it is basic property, upper basic property. It says that upper approximation of phi is phi, and this upper approximation distributes over arbitrary union. Then we can show that there exists unique binary relation rho G such that the lower approximation by this operator, lower and upper approximation by both these operators are exactly the same lower upper approximations through the relation, this relation rho G, and this is the way of construction this relation. And as this L and U prime both are dual with respect to quasi-complementation, and therefore we need these two lower basic properties to hold the same relation, same results. And this is for other these are basic. So for lower operator these are basic, and for upper operator these are basic, and for lower operator these two basic. And when we add one by one properties, so suppose here we add this axiom, and for L this axiom, and for that axiom we find a unique serial relation such that this happens. And for G serial relation we need these two axioms, and for reflexive with these two axioms, and for other this G symmetric, G tangential and mediate relations, and for this G Euclidean, G image equality, G identical. So these are the some references. Thank you.
Any question from the audience? Anyone?
So just one question. Is there any comparison between these two existing ideas? Because in many journals now they need a comparison to which one is better. That is your idea or the existing.
So actually I don't have no application side of this theory, okay, but rough set theory has definite some application area, and that's why I do not say exactly which is going on.
Any other question from anyone? Okay, so if there is no other question, so let's thank Murshida again one more time. Thank you, Murshida. And the talks, the formal talks, we are ending here. I'm handing over the mic to Shankhoda for 5 to 10 minutes valedictory session.
Don't even know what I'm supposed to do. So this is, I'll just say, okay, thank you for, let's thank the hosts, Saurabh and Pulakda for the efficient organization. Thanks to Ramakrishna Mission for again hosting the conference for the second time. This is becoming our standard venue for the CLC annual meet. I don't think there is much to say other than that. Thanks to everyone for coming. Thanks to Ramakrishna Mission once again. I don't know where the next meet will be. There is some things floating around, so it could be Ramakrishna Mission again, it could be St. Xavier's College. We will see. But this was a prime numbered annual conference of the CLC. That is something to be noted. I don't want to put anybody under the spotlight, but Amit, if you want to say a few words, because this is the first time you're coming.
No, it's the second time.
Second time, okay.
Main point is that actually those who are attending the conference, again, I am not being much satisfied. That's my point. So I want to have suggestions for, okay, what kind of things you expect next. That's all, yeah. That's why
Very hard to give suggestions, I guess. Kamal, you have something to say? It's actually very hard to give suggestions. I think one of the things that can happen for next year is that if we start preparing early and then we send out invitations to more people so that we have more of an audience.
Audience, actually this time representation from philosophy stream is very poor. And this should not be. On the other hand, representation from the computer science stream was better, quite strong. So that is good side. I will say representation from mathematics stream is also not that good. I mean, in the sense that except one or most probably one, except one lecture from mathematics, I perhaps will not appreciate much. I mean, there are definitely a few lectures, but one was quite good, very good. But so what I expect that two things. One is the spread, that is various streams coming in, 3 streams basically, is one. And the second thing is that quality. Although in this our Logic Circle program we never actually scrutinized scrutinized papers or scrutinized presentations. That was not our culture. That's true. But at the same time, we should invite some people who will not only from abroad, but maybe from within us, from India, inside, who will be sure that they will speak on something which is really very important. So that is what I mean to say. Of course, I don't say that quality was very bad. No, not that. Because it was presentation, standard presentations. But but at least a few should be of quite high quality things. I mean, quite informative and quite, from all streams. For example, we missed Amita's talk this year. It would have been a real addition because she was going to speak on Arabic tradition of logic. And what she just told me a little bit was really fascinating. She wanted to say, apart from logic, a bit of history also. I mean, the entire history from from, say, Baghdad to Lucknow. So the madrasas from Baghdad to Lucknow, they taught logic there. That's quite something. I mean, some information to us, because we have some understanding of madrasa. That will be, totally, Anyway, so that some.
The timing is not actually good. I'm not teaching, so I'm here. If person is teaching, this
Okay. So that is very important point. Good point. So what time do you think? I mean.
Definitely not term end.
Definitely not. No.
Term end.
No. Term end, is it the same all over India?
But you have to care about all the people who are.
Most of them.
Yeah. So October will not be a term.
But you see, each time, I mean, last few years, we had been we had been organizing this in October only.
No, like what he's saying that October is going to be probably the good time.
Good time?
Yes.
Oh, good time.
Yes.
Okay.
I have declined invitations in the past because if I'm teaching, I can't.
So this is very good session.
Just one thing, since Amitadi's talk was missed and it was on Arabic logic, there is a conference announcement that came recently. This is the inaugural symposium on logic in the Arab world. This is in Kuwait University next year. Many of you already probably know, and this is on 18th and 19th of February 2025. The keynote speakers include Graham Priest, Gillian Russell, Suki Finn, Eduardo Barrio. So it should be a very interesting conference. The last date is November 25th for submission, yes. Anyway, so let's end the session and also the 23rd meeting of the annual conference of the Calcutta Logic Circle. Once again, thanks to the hosts, the department, the college, and of course without the people handling the recording, the audio, and the other things. I mean, I don't know what all things you had to manage. Thank you to all of you. Thank you.